Greetings, everyone, and welcome to the Pan Future Podcast. Today is Saturday, November 4th, 2017, and as per the current cycle of things, it's an all-news show today to catch up on some of the latest and greatest. Today we'll open the show with a quote. I've meant to deliver quotes more often, and I keep forgetting, so I'll make up for that today anyway. The quote is, "Science makes people reach selflessly for truth and objectivity. It teaches people to accept reality with wonder and admiration, not to mention the deep awe and joy that the natural order of things brings to the true scientist." That quote comes from Lise Meitner, an Austrian-Swedish physicist who worked with radioactivity and nuclear physics. She, along with Otto Hahn, led the small team of scientists who first discovered nuclear fission in uranium when they found it to absorb extra neutrons, and these results were published in early 1939. This led to, unfortunately, nuclear weapons for one thing, but also nuclear power and other nuclear reactor technology and all that. So an example of science being a tool, what you end up doing with your knowledge is different than the existence of that reality in the first place. This quote's also noticeable. I guess I would think Lise Meitner is noticeable because she was overlooked for the Nobel Prize that was awarded for this research. 1944, the Nobel Prize in Chemistry was awarded for nuclear fission, and it was given solely to Otto Hahn. That is certainly an oversight, and she is not the only woman to have been overlooked by the Nobel Committee, particularly in those who were part of teams who did research. However, at least slightly making up for that, she received a number of posthumous honors, including the naming of chemical element 109 Meitnerium in 1997. She lived from 1878 to 1968. And again, Lise Meitner, physicist, discoverer in part of nuclear fission, with our quote to start the show today. And with that said, no other rambling from me. Let's just get right to the news of the moment. First item on the news list today: scientists in China have developed several types of rice that can be grown in seawater, potentially creating enough food for 200 million people. This comes to us from a field near the Yellow Sea coastal city of Qingdao in China's eastern Shandong province. 200 different types of grain were planted to test which would grow best in the salty conditions. Seawater was pumped into the fields, diluted, and then channeled into the rice paddies. They expected to produce 4.5 tons, that's metric tons according to this article, from the Independent out of the UK. 4.5 tons of rice per hectare, but the crops exceeded those expectations, in one case delivering up to 9.3 tons per hectare. The test results greatly exceeded our expectations. Liu Shiping, a professor of agriculture at Yangzhou University, who is involved in the project, told a news agency. In China, there are 1 million square kilometers of land where crops don't grow because of high salinity. These low-lying sort of marshy areas with a lot of salinity, and they hope that development of these new strains of rice will help allow some of these areas to be used for agriculture. As the article states, if even a tenth of these areas were planted with rice, they could produce 50 million tons of food, enough to feed 200 million people, and boost China's rice production by 20%. So that is remarkable. And given the need to bring more food stability to many places all over the world, this is great research. Also, in the future, fresh water is going to be harder and harder to come by. So being able to do something with seawater, whether it's directly growing food in the seawater or desalination for other uses, is going to be absolutely necessary. The article goes on to mention that this new type of rice was developed by a team who has spent decades crossbreeding and doing things with rice to grow in different conditions, and they've been investigating how to grow rice in salty water since the 1970s. Mr. Yuan, the lead researcher, said, if a farmer tries to grow some types of saline-tolerant rice now, they most likely will get 1,500 kilograms per hectare. That is just not profitable and not even worth the effort. So it doesn't directly say here in this article, I don't believe this particular rice is directly modified on the genetic level. It looks like it was developed by years of painstaking crossbreeding. However, I would imagine going into the future, we may be able to achieve these goals much quicker with modern farming technology and modern genetic modification technology. Instead of spending 40 years trying to figure this out, we may be able to do it in a quarter of that time or even less. But good news all around on the food front there. Some news on the music front, which is of special interest to me since I am a musician most of the time when I'm not podcasting. There's a new concert hall that opened in Hamburg, Germany called the Elbphilharmonie, and the exterior of the building is gorgeous. It looks like a wave. The interior is like sort of an organic Escher-like thing. It just looks beautiful, and by all accounts it sounds amazing. Now, one of the most interesting things that makes it sound amazing and why it's on the show today, the main auditorium, the largest of the three halls in the building, is the product of parametric design, a process by which designers use algorithms to develop an object's form. These designers use these algorithms to shape individually 10,000 gypsum fiber acoustic panels that line the walls of the auditorium. Now, when you're trying to design a large space, or really any space for acoustics, but in particular large spaces, the idea is to break up some of the reflections so they don't overpower the music. You don't want parallel walls and distances that are squares of each other, because you get things bouncing around weird, and the reverb waveforms can multiply each other. There's of course, the whole science of acoustics behind this, and it is a science, but now we're seeing this application of new algorithms getting really into some fine details, and just it's mind-numbing to me to think that they design 10,000 individual panels to work with each other to optimize the sound of this, not just in general, but one of the hardest things to do in a large space is to make the sound optimized in every seat in the house. Does it sound as good up close as it does in the cheap seats where I usually sit in a place like this? And this has certainly gone a very long way to doing that, being able to instead of having to do this by hand or do some extensive calculation using computer algorithms to design all these individual panels. It's quite remarkable. So I would imagine that we will see this more often in new designs for concert halls. And, of course, lots of other spaces use acoustic treatments as well, like offices, to just make it a more pleasant environment. So you may see this algorithmic design turn up in office buildings or homes or sports stadiums or who knows where. But I wouldn't be surprised to see it turn up in all sorts of places. In some earth science-related news this week from Science magazine, researchers think that possibly the sloshing around of Earth's core may spike major earthquakes. Now, you may or may not know that every so often the Earth slows down. And for decades, scientists have charted these tiny fluctuations in the lengths of the Earth's day. These are very small, milliseconds here and there. It can speed up very tiny bit, slow down just a very tiny bit. But now at a meeting of the Geological Society of America recently, two geophysicists argued that these minute changes could be enough to influence the timing of major earthquakes and potentially help forecast them. They found that during the past 100 years, Earth's slowdowns have correlated very well with periods of increases in earthquake activity above a magnitude of 7. This research comes from Roger Bilham of the University of Colorado in Boulder and Rebecca Bendick at the University of Montana in Missoula. And this spike in correlations adds 2 to 5 more quakes than usual, and it happens well after this slowdown, this periodic slowdown. As quoted here from Bilham, the Earth offers us a 5 years heads up on future earthquakes, which is remarkable. Now, as many people have said, and seismologists largely agree, the earthquake prediction is, as they say here, a minefield. And so far, this research only kind of gives us a difficult-to-test idea of what might cause the pattern that they found. However, this points in the direction of future research to try to more accurately predict, or even predict at all, earthquakes. Another element of the research here seems to show that these oscillations between the Earth's core and the crust kind of reinforce each other and cause these more strong earthquakes and cause peaks in a cycle. Similar to how I just mentioned that reverb bouncing around in a room can, those waveforms of sound can multiply each other and reinforce each other and make it sound bad. We have a similar kind of thing going on here with earthquakes. So I will link to this article. It's worth reading. Some of it's a little hard to think through in front of a microphone like this in terms of the details of the kinds of correlations that they found. But I also do keep saying the word correlations because in science we should all know that correlation and causation are not the same thing. So at the very least, they have found a very interesting set of data that lines up a certain way and certainly needs some more examination and further prediction and testing to see if any future earthquake prediction is possible. And that's how science works, right? Sometimes when I dig up these stories, I find things like this, and we're sort of kind of in the middle of the process. This is from Science magazine, so it's giving us an accurate picture of research that is ongoing and underway. If this article were to be picked up by a mainstream news agency of any kind, the headline would probably read, "We can predict earthquakes now." And that's not what this means at all. Science is a very incremental, step-by-step process, and read the article and get a little peek into some of the middle steps to this process of understanding our planet better. And it's just fascinating to think, out of how much stuff we know, there's so much we don't know about our own planet because we can't get there. We probably know more about our solar system than we know about the interior of our planet. I don't know. Somebody correct me if I'm wrong about that or if that's just a bizarre metaphor to make. But anyway, I'm rambling now. So it's very cool research on earthquakes, and let's keep track of it and see where it goes. And now, it came from outer space. Perhaps the big story in space news this week that you've probably already seen is the detection and examination of an object that appears to be traveling through our solar system from somewhere very far away and will leave the solar system and never come back. This is an extrasolar object of some sort. On October 19th, astronomers at the University of Hawaii's Pan-STARRS 1 telescope discovered an object, possibly an asteroid or a comet, measuring 400 meters in diameter and traveling at 25.5 kilometers per second. This is apparently very fast, and judging by the speed and trajectory, astronomers believe it is not from within our solar system, not even something that would have gotten kicked out of the Kuiper Belt or the Oort cloud. And it is now on its way in the direction of the constellation Pegasus at a remarkable 44 kilometers per second. These speeds are extremely fast for celestial objects, and one researcher, David Farnocchia, he's a trajectory expert at NASA's Jet Propulsion Laboratory in Pasadena, said, "This is the most extreme orbit I have ever seen. We can say with confidence that this object is on its way out of the solar system and is not coming back." So very interesting. This is something astronomers and astrophysicists have figured happens from time to time. It is believed there are objects, not every object in the galaxy is tied up to a solar system of some kind. There are rogue objects flying around out there, and as much empty space as it is out there, I think it's kind of remarkable that one flew through our solar system here. So that was the big space news this week. Moving on. A new telescope has been put into use this week at the Mount Palomar Observatory in California. This instrument, called the Zwicky Transient Facility, turned its eye to the sky for the first time this week. And the aim of this new telescope is to catalog thousands of supernova a year and catch other fast-moving celestial events. This is a repurposing of the nearly 70-year-old Samuel Oschin Oskin telescope on the Mount Palomar Observatory. And it has now a new camera, including an array of 16 charge-coupled device detectors, and has a field of view 200 times bigger than the moon, so it can photograph the entire northern sky every night. And by doing this and comparing these images from night to night, the ZTF will log exploding and variable stars, near-Earth asteroids, and active galactic cores. So, great news in the world of observation. We've got a new tool pointed to the sky, seeing what there is to see. Final piece of space-related news this week. The NASA twin study spots thousands of genes toggling on and off in Scott Kelly. So you may remember I've mentioned it on the show. You've seen it elsewhere. Astronaut Scott Kelly spent a year aboard the International Space Station, and one of the remarkable opportunities that this brought was to compare his experience with his identical twin, astronaut Mark Kelly, who stayed on Earth. Now some of the results of this study are starting to come out, and one of the things that they found was a large increase in Scott's methylation rate. Big words. This is the process that turns gene activity on and off. They documented thousands of genes switching on and off as soon as Scott entered space, and that state continued for a short time after his return. Saying of this result, there are over 50,000 genes in the human genome, and when floating in zero gravity, the body is trying to manage that situation in new ways, says Chris Mason, one of the principal investigators in the twins study. He also says both DNA and RNA were found to express genes in order to compensate for a lifestyle in space. Now, this gene expression really just means it's the process by which our genes produce protein, and these proteins in turn build our cells and regulate cell activities. This is a key to the body's ability to deal with stress and the development of diseases. For example, low oxygen levels can switch on certain genes so the body can survive, while exposure to excessive radiation can mutate genes so they're always off or on, which can lead to cancer. Another finding here is that Scott's telomeres, these are the caps at the end of your DNA strands, grew longer while he was in space. The longer telomeres basically means the signs of aging are either stable or decreasing. As we age, our telomeres shorten. They get short enough, we have DNA problems and mutations and cancers and things like that. The downside, though, is longer telomeres in place with higher levels of radiation, as you would have in space. The cells are then also more likely to mutate and become an extremely aggressive cancer. Also stated as part of this research, they're planning to use tools such as CRISPR-Cas9 and other genetic engineering methods to prevent methylation from causing detrimental genetic effects. So this isn't something they're going to try out on Scott right now, I think. But they are actively researching this for use for astronauts in space or on their way to Mars. So there you have some research resulting from the NASA twin study, and what a remarkable opportunity. So few people have been astronauts. The chance that we just happen to have a set of twins to study is a remarkable resource for future space flight. All right, there's your show for the week. Thank you so much for joining me again. I hope I've brought you up to speed on some of the latest news here. As always, you can go to the website at panfuture.org, click on the podcast link, and take a look at the show notes. You can see the articles I've gotten my information from here in case I have not explained something very well, which is entirely possible since I am an enthusiast and not an expert here. But I hope you learned something today. Like I said, go to the website, find me on Twitter and Facebook and all that. If you feel like helping out, there's a Patreon link on the page for a regular thing, or you can just do a one-time thing with the PayPal link that is there. Also, always share it with your friends, review it on iTunes or wherever you get your podcast from. That is extremely helpful. And I hope you have a fantastic week. And as always, I will talk to you again in the future.